Hi, everybody. This is our webinar on sustainable greenhouses. My name is Tara Wilsworth. I handle marketing for Prospient. We have some guests on the show today. Stegan Eggers from BOAL Group in the Netherlands. Burk Metzger, Burk, Tony, and Joe, the next three, are all from Prospient in the produce division up in Canada. So with that, I'll let them introduce themselves a little, just speak about what they are, what they do, and then we'll get right into it. So Stefan, do you want to kick us off?
Yes, well, my name is Stegan Eggers. I'm working at BOAL. We're one of the leading manufacturers in roofing systems for greenhouses. For 1 year now, I've been in charge for the ESG director for sustainability, and I'm happy you invited me to talk about what we think in the heart of horticulture in the Netherlands are the new ways to be more sustainable.
Thank you.
Hello, everyone. My name is Burk Metzger. I'm the GM for the produce business at Prospient. I spend a lot of time in Kingsville, Ontario, our local greenhouse hub here in Canada. I look after everything large-scale produce project related at Prospient. We have our main manufacturing hub here in Kingsville, and we execute produce projects nationwide, US and Canada. I have a background, I've been too long in the horticultural industry, about 30 years already. I'm getting old. I've been with Prospient for 2 years now and about 1.5 years in the GM role here.
Thank you.
Hey everybody, my name is Tony Abbas. I do strategy and business development for the produce division of our company, Prospient. I've been in the industry for about 12, 13 years now, ranging from media sales and working with customers on their growing strategies to a little bit of a bout in cannabis. And then I came into this role here at Prospient. We at Prospient build turnkey greenhouses, and we do this for customers ranging anywhere from the United States to Canada. We have a lot of experience. We love what we do, and that's kind of us in a nutshell.
Thank you. Joe?
Hi, everyone. I'm Joe Slikboer, estimating manager at Prospient, located out of Kingsville here, focused primarily on large-scale produce and produce projects. I've been at Prospient for 4 years, estimating, and we do a lot of preliminary design in the estimating, and we have to be educated on new technologies and how they can impact future builds.
Thank you. And then, as I said, I'm Tara. I forgot to mention about questions. If anybody has any questions, please use the chat function. I will read them out as they're asked so that they're answered in context. We don't need to wait until the end for Q&A, but if you have any questions at any time, just type them in the chat and we can answer them then. All right, with that, Burk.
All right. I want to take you guys all through an overview how we, from our perch, see the industry. It's going to be a little produce-centric, but I think it's very interesting. So U.S. solidly in second place worldwide in terms of horticultural market. That includes field and floriculture. It's about a $32 to $35 billion industry worldwide. And greenhouse production has a growing share of that market. From a produce perspective, how is this industry structured? We have a hub here that's very big, and some people are aware of it, some people aren't, in southwestern Ontario, mostly here in Kingsville, Leamington, close to the border to Detroit. And this whole production cluster is focused mainly on the US market. The export percentage of the stuff that we grow around here is over 80% actually hits the US market. From an owner perspective, here in Canada, it's mostly the owners have an owner-operator background. There's a lot of operational experience. Our bigger growers have now financial partners, and they have had several rounds of private equity, and they're growing into multi-billion-dollar companies. But there's a strong operational background here. On the US side, outside of floriculture, we see more an investment-centric ownership structure. Then sometimes in these situations, we have limited operational experience. So what's driving this industry growth on the greenhouse side? There's consolidation going on the retail side, and this consolidation is met on the producer side. There's an ask through that consolidation, the producer has to supply the whole category year-round with consistent volumes and quality. So you can't just be with your own marketing a single tomato producer. You have to be out there and say, hey, I can give you the whole tomato category. I can give you cucumbers, peppers. And lately, this category has expanded that now the demand is hothouse grown berries and hothouse grown leafy greens. The last driver we see is climate change and labor issues are pushing traditional field players into the hothouse space. What's hindering the growth? It's very capital intensive. If you have a specialized leafy green greenhouse, investment can be more than $2 million an acre. Energy costs and labor availability are a restricting factor as well. So now this webinar is about sustainability. Where does that come into play? Sustainability is important to mitigate energy cost and increase profitability and other input costs, and we get into the details of that. There's also demands that the public puts on us through policy and retailers through their policy to have a sustainable production system, and a greenhouse production system is well suited to that. We can, through the sustainability aspect, position greenhouse growing systems as more sustainable versus the traditional growing systems. What do I mean by that is water consumption, carbon footprint, distribution miles, food safety, and food security. That's where sustainability and greenhouse growing come together.
Well, can I add to that the items you mentioned, like labor shortage and also energy consumption, it's the same in Europe. That and also that's pressing us as well, and also the capital that is required to have a real high-tech greenhouse is expanding due to all the computerized systems, etc. But it also gives a lot of opportunities.
Also the demand to have close by freshly grown fruit and veg all year round. You can't do that in a field when you've got 6 inches of snow outside growing strawberries. It just doesn't work. So you have to have that close by. All right. Future trends. We're moving into Stefan. This is his wheelhouse. So Stefan, you want to take this away?
Yeah, well, last year as the BOAL group, or like 1.5 years ago, we really started in looking at what's happening around us, and also that we see that society starts to understand that we need to be more sustainable. Otherwise, we won't have our future generations won't have it as good as we have. But that's also quite a challenge, especially like in Holland. We always had quite cheap gas, but now with the war in the Ukraine, prices went up from like 20 euros or like $20 a megawatt hour to 350. So there's a lot of pressure on that side. But that's not all. If we want to be sustainable, we in previous years we said, but the outcome of a greenhouse is very green and is very good for everything, and you've got a great yield on from a greenhouse without that much water, etc. But when we then looked into it and say, hey, if you look at it from a broader perspective, it is also the products that where we have to take care of, and the building products for a greenhouse that should be sustainable, because we really believe that the consumers in the near future will say, hey, I don't want to have only sustainable food, but it needs to come from a sustainable greenhouse. Otherwise, I will also have quite a footprint on the global Earth. So for that, we started the journey, and we in all kind of ways, and we said, well, if we want to have sustainable products, what's possible, what should we do, and what's the direction to go to? So And we've got several businesses. We've got the greenhouse roofing business, which we use aluminum for. We've got sandwich panels. We've got screens. We've got insect netting. So we took a look. We took a look at the complete portfolio. And if you can present the next slide, I will show you what we did, or what we think we're looking at for all our products. So aluminum is a great metal, because you can recycle it time after time. But to get to aluminum, it's really energy intensive. It's so, and when you talk about energy intensive, you also already talk about your carbon footprint. So we're currently looking at reducing our Scope 3 carbon footprint by getting an optimal mix of aluminum, which is produced by hydropower or which is recycled. And so by that, we really our strategy is to at 2030 we will have to reduce our carbon footprint in our Scope 3, so in our aluminum, with 40%. So we're now catching up with our suppliers, and the aluminum industry is really pushed also by getting lower carbon emissions. So we are looking at to halve our carbon footprint in 2030 with our greenhouses, which has a really big effect. So that's from the aluminum perspective, but also from the perspective of a grower, energy is costly, and we try to understand, or we understand it, and we try to see how we can change that. So for example, where growers start with one screen, it's very common in the Netherlands to have a second screen, but now we're already talking about companies or growers who have 3 screens, and by that they are really lowering their energy consumption. If you go to the next screen. But also getting all the getting the pesticides out, and which is a challenge. We have our netting system, but then people will say, well, the netting system have also got some disadvantages. So we're really looking at a way and a type of growing how we can overcome these disadvantages and get it growing in such a way that with the netting and without pesticides we have a really good yield. So those options and this way of thinking really gets you to a position where you, every time you say, hey, where can I improve? How can I provide to my customer? Prospeon is one of our biggest customers, a good product which really is sustainable, and it's in all kinds of way, because traditional we use glass, but you also got ETFE foil, and then you really reduce, for example, on transport emissions. So we've been looking to that, and we're in the process where we think in 1 year we've got, for every product, we've got a greener option. We can give to the market. So in that perspective, that's looking where we can improve. How can we be sustainable to get this the tomato or the cucumber more and more sustainable as well. So that's our challenge, and also for all other things we're looking into, for example, recycled input. If you take it to the next slide, I will. We've got screens where we have recycled input without compromising the quality and functionality of the product, because that's really important. But also we have our sandwich panels. We have it in such a way that there's no sealant required, and in that way, BOAL tries to bit by bit get the complete horticulture business more sustainable from its side. So we really see this as the future in horticulture, is that also not only the product is sustainable, but also the greenhouses are. So if you've got any questions on it, I'm happy to answer.
Those photos on the right there, where it is created from recycled input, is that like are those at the top the recycled inputs that you come in and then?
Yeah. So from our supplier of the screens cloth, from bottles they make new granulate, and from that they make the product where we wave the screens from. So, and what you will see that more and more this is common practice. Like Nike will have sneakers with recycled input, and also large car manufacturers, the seats, etc., are done with recycled input. So we believe that this will be the normal way of working in 5 to 10 years, that all the products, or probably governments, will require that a certain amount of recycled input will be in your products.
Okay. Again, if anybody has any questions, just put them in the chat and we can answer as you ask them. So moving on to specifics about the actual greenhouse, we have Joe, who's going to speak to the next two slides. Joe?
Yep. So on a large-scale greenhouse project, you require what we call stormwater management or rainwater management. Essentially, when you have a large square footage of ground covered, you're going to have the rain runoff from the roof when it rains in the area. So you have to control discharge into the local authority, or the municipal drain. And this water can get up on a large scale project to up to or over 20 million liters of storage required. And then with water conservation in mind, it kind of comes to mind, well, how can we use this water? How can we take advantage of this excess water? And that kind of leads into what we call a rainwater recapture system. You can do this a couple ways. Typically, how it's seen is you have a pumping station connecting to your stormwater pond, where the water will be filtered, sterilized, and then reused in the fertigation process, essentially. And then to further increase water quality in your pond, you can actually add in a liner to your pond or cover your pond, and that'll control algae bloom as well. And after talking about what happens to the water outside of the greenhouse, of course, we got to consider what happens to the water inside the greenhouse. So typically how that system is set up is you have fresh water, which in a typical greenhouse, you can see up to 40,000 liters required per acre, which is quite substantial. So supplementing that fresh water that you need with the rainwater is obviously ideal. And in the typical process, how it typically goes is the fresh water will feed a fertigation or injector unit, where that fertilized water is then transported to your plants through a drip irrigation system. And then the hydroponic gutter will collect what we call leachate after it's ran through your plants. And with that collected leachate, we pump it back through a particulate filter. Then we can sterilize it and actually reuse it in that process, which then can supplement your freshwater consumption and your fertilizer consumption, which is ideal for most growers.
So once the water comes in, it's a closed loop system, effectively.
Exactly, essentially. Yeah. So you can reuse both fertilizer and water. So then it becomes kind of a combined venture with the fresh water and then the sterilized leachate.
Okay, and you've mentioned this before, but how many gallons are required per square foot or something, for...
Yeah. So the freshwater consumption can be up to 40,000 liters per acre, but it usually doesn't exceed that number.
Which is quite a high number, really.
Yep. But if you consider the rainwater, the rainwater runoff, where you can see up to 20 million liters stored, you can see how it would be ideal to reuse that in the process. And it's something that we've been exploring and we've seen and we've done on a couple large scale projects, and it works very well.
Mm-hmm.
On top of water, plants also require CO2, which is a very essential very essential process in photosynthesis. And to produce this CO2 in a large scale venture, you usually see it done via natural gas boilers. The issue arises then when you need CO2 but you don't need heat, because when you run those boilers, you produce both heat and you produce CO2. So what we've done is we typically install a hot water storage tank on these projects. What this allows us to do is you can produce your CO2, and then that heat, the hot water byproduct, you can store into a hot water storage tank, which can be used later when it's required. And since it's an insulated tank, it'll retain that heat a lot better. And how you can reuse that heat is actually running it back through your boilers, where it requires obviously less energy to get to the temperature required, or you can pump it directly to your range and use the heated water that way in your hydronic heat system.
What temperature does it store at?
Typically 90 degrees Celsius, just around there. You can go a little bit hotter, but that's typically where you see it.
Okay.
Yeah, the key takeaway there before you advance, and sorry to jump in there, Joe, but the key takeaway here is that there's the crop itself wants CO2. When the sun's out and the plant is wanting to be active, that CO2 bursts its uptake from a photosynthesis perspective. So running your boilers to create hot water during the day is not needed to keep the greenhouse warm now, because it's warm outside and the greenhouse is already warm. So Joe's saying we can actually, we cook that water, instead of using it in the greenhouse itself, we store it in this giant tank outside. But because we're cooking that water, that CO2 is coming in, getting distributed throughout the crop. So now your crop's really receptive, active, and wanting to grow and create fruit for you. And then in the evening time, when that temperature comes down lower and you want to heat your greenhouse, you take advantage of that product or that heat or the hot water you had made earlier in the day and use it at that time, instead of always constantly running a boiler and spending money on natural gas. And that's the key takeaway here is you're making a product that you can store and use for later. This is just reduces and makes your greenhouse more sustainable.
Yep. Yeah, exactly. So you might not have a heat demand and a CO2 demand at the same time. And essentially this allows you to meet your CO2 demand while not wasting the heat that's produced in that process, and vice versa, right? Where there's times where you need heat and you don't need CO2 for the process. And that kind of leads into the next slide here, which is a CO2 collector. So essentially what we do here is we set up an aluminum manifold that'll span and connect to a CO2 condenser on the natural gas boiler. And the CO2 condenser, we have that in there purely to increase the efficiency of the boiler. Kind of takes advantage of the flue gas heat, and then it increases the efficiency of your boiler. But what this manifold lets you do is you only need to run one boiler to produce CO2. So when you have those times where your heat demand isn't in that full flux, but you have a CO2 demand, you can run a single boiler. It's not producing as much heat, but it is producing the CO2. And then on this manifold, you have multiple CO2 blowers, is what we call them, which is used to distribute the CO2 into the range. So one boiler then can feed multiple CO2 blowers, and then you're not producing as much waste heat that's going to the hot water storage tank to be used for later.
Are all greenhouses sustainable to some degree right now, or are some just have nothing? This is a general question, really.
Yeah. So typically you do see some technologies that are green or taking advantage of what's there, especially when it's both economical and environmental, because it's kind of a win-win situation. For example, like a CO2 collector, if you have multiple boilers and multiple blowers, it's a great idea to have in. It's nice and green. You don't have to consume as much natural gas to produce your CO2. And same with the hot water storage tank, where you can produce CO2 without worrying about wasting your heat, where it's both economical and environmental for the grower and the operator of the facility.
No, unfortunately, Tara, no, not all greenhouses are sustainable. And to answer that, it would be more or less the evolution of, right? When we came from a field concept, then it came to protecting from elements and putting a structure of some type over, and then it came to managing the environment better. So let's close that structure. And then it's just exploded from there from a technology perspective. So older greenhouses existed for certain reasons and certain needs, and they were climate and area specific, right? So now when you talk about a sustainable greenhouse today, thanks to the technology and what's been put into this greenhouse growing concept, you could literally plop a greenhouse anywhere, no matter what the climate from the outside perspective is or where the location is, and maximize and be as sustainable as possible to produce that crop because of technology available. So
what about the existing buildings? Is it easy enough to retrofit to make them sustainable, or is that not even?
Like again, it depends on the situation, right? Most situations, again, the age, the type, those are key. But in most situations, yes, you can increase and add things to a greenhouse. And you'll see in the next stuff, like, when it comes to a screening system, for example, you can add to a greenhouse that would increase your R value, maximize your light. And not to get into it too much as it's the next slide, but you can bring in a closed loop water system, have a gutter system where your plants are sitting up instead of on the ground or in the ground. You can have them suspended from the structure itself. So it's not ergonomically easier for you to get to the plants. You have an easier way to distribute water, collect leach or collect what the plant doesn't take and reuse that. You can add that to a system, into a structure, depending on what it is. But yes, you can. It is possible.
And I think we can't lose sight of it's a relative thing, sustainability. It depends who you compare yourself to. It's not I'm not or I am more or less sustainable. If it comes to water usage, any greenhouse is more sustainable than field crops. When it comes to use of space, it's more sustainable than field crops. Then it comes to these systems on top of it where they become more sustainable than the average greenhouse application. A lot of these are in the newer designs are mainstreams, collecting CO2, heat storage tanks. It's been around for quite some time. The energy crisis now, the focus on having somebody putting a cavity screen and another screen, like 3 layers of screening in, that's a result of the circumstances that we have right now. Mm-hmm. The other development that we're seeing in part is the heat storage tank / CO2 dosing application. We cannot really store the one component, the CO2. We need to make it when we need it. There is applications now, they're biomass based, where we start to store the CO2 and we use it exactly when we need it. So you are uncoupling this demand from when you produce it. So you can have a steady production process. You can store the CO2 and the heat, take those components and use them when it suits your crop. That's something that's on the horizon. Those are processes out of the petrochemical industry where we can actually absorb and desorb the CO2 and in its pure form store it in a bubble and then take it out of there. That's successfully been done now in Holland and in Germany a few times.
But Tara, coming back to your question, is every greenhouse sustainable? If we look at the number of people on the planet in the coming 20 to 30 years, we have to produce so much food that it can only be done via greenhouses, because otherwise we won't have any forests or won't have any nature left, because then the demand for food to grow it on a normal acre, it's hardly impossible to do that for all the people in the world then. So I think, or we really think that, greenhousing is the sustainable way to go forward.
Okay, my turn. So we talk about screening systems. We talk about shade systems. So climate screens, essentially we use them in a greenhouse to control humidity, temperature, and UV radiation. And what the point of it is basically making the greatest or most optimal condition for you to have better production and have a better environment in your greenhouse. At the end of the day, you have plants inside of a farm, inside of a structure. They are living, they have a purpose, they want to make fruit, they want to get as much sun as they can, they want to produce. So using a climate screen or a climate screen system enables you to truly make a very optimal environment for your plants. So we use a screen system to basically move those screens, or to move the material, screening material, back and forth. So extending and retracting those screens. And with that screen system, you get that over the day, throughout the night, control of the environment, enables you to have a better grip of what you want for your farm. One of the biggest and most popular ones that we use is an energy screen. An energy screen reduces the heating cost because, taking it a step back, we build a structure. You take a steel frame, you make a structure out of that frame. We cover it in either glass or, polycarbonate, or, as touched on before, foil now, which is new technology coming to the industry. And once you do that, you still have you have a closed building essentially. You want to take advantage of sun. You want to bring as much light as you can in from the outside because that's free to you, right? And that sun's obviously great for the plants. So with the use of a screening system, we keep the environment within the structure itself. So we keep that optimal climate within. We close our screens, and an energy screen, for example, lets as much light as possible through, but doesn't let that environment, that temperature, that humidity, that ideal space out of the greenhouse. It keeps it within. So taking it even further, think of it as insulation essentially for your greenhouse. So instead of us, and we can put the screen systems on the walls, so we can put them vertically, and we can put them actually on the top of the structure itself as well. So that the use of screens has an R value to it. On top of that, you have many different screen material that you can take advantage of, right? There's some that will take the light that's coming in and diffuse it, so scatter it, right? So it's basically a screen for diffusion. So as that sun comes in and you're used to seeing a shadow, for example, like say you put your hand in front of that light or in front of the sun, you'll see a shadow. A diffusement screen takes that and scatters it, so you don't see a shadow. And it just gives a better distribution and disbursement of sunlight. So you're hitting all sides and all angles of the plant, right? Encouraging the growth, right? There's other screens that are like blackout screens, for example, where we can basically manipulate the daytime for plants, because certain plants operate, cannabis, for example, other plants that operate, orchids, that need dark and that need to have that controlled. You can use a blackout screen system to do that. You know, there's screens that offer solar protection. There's screens that offer better thermal protection. Like there's many different screens. And as we kind of touched on before, there's the opportunity to put in multiple screen systems. So having, one layer of screen, a second layer of screen, or something else that's coming to the industry now is the cavity screens. Where on that same profile, so on that one moving system that pulls that screen back and forth, you can have 2 to 3 curtains. That increases your R value significantly. So for, we touched on it before, older greenhouses that are not very tight, that may be a poly greenhouse, and those greenhouses could benefit from this, as well as existing ones where we use the minimal amount of gas to heat this thing up as possible. We keep that climate within as much as possible because now we're adding more R value, and obviously heat goes up, right? So we try and retain and keep everything within the structure as much as possible to reduce what your costs are to create produce, right? So that it's a big part of our game and our industry. Next screen, please, or next slide, sorry. Then the next thing we talk about air baffles. So air baffles are, you can kind of see in the picture, they're basically a vertical screen that we put up in the peaks of the greenhouse themselves. So if you picture above the actual screen, the screening system, we put these screens up there to manage the temperature gradient across the whole greenhouse. So instead of having that one open peak where there's an ability for that air to be mixed, and when you open your curtains, that air comes down, having smaller sections essentially by putting these air baffles in makes it much more manageable and doesn't allow for that gradient to exist. It's more uniform. So it's things like this that bring that temperature, that environment to where you want it to ideally be. So we're lucky in the sense that greenhouses have evolved, and they've evolved relatively quietly. Like Burk had touched on, you talk about where there's large footprints and large amounts of greenhouses, and they're the biggest from a high-tech developed commercial production perspective is in Holland with our colleagues here at BOAL and in Holland now. And then, second to that is the area here in this Leamington, Kingsville, Southwestern Ontario. area where there is a lot of greenhouses that are tried, tested, and true. The good thing is with these greenhouses and the need for them, the evolution and the technology has been amazing. Like to touch on some of the stuff that my colleagues talked about here, you know, we're talking about like literally bringing water and nutrients right to the plant itself and letting that plant take what it wants and what it needs. What it doesn't want and what it doesn't need, we collect all of it. We bring it back into a closed loop system where we remove sediment and then we clean, we sterilize, and then we're reusing that water in when we feed the next time. So it's a closed loop system where nothing goes to waste. So when we talk about the inputs, significantly less with the greenhouse. And what you pull from a greenhouse, you know, when it comes to a traditional tomato crop or a traditional tomato or pepper crop or whatever it may be, you're running these crops for 8 to 10 months out of the year. You're pulling produce from these crops. You're pulling fruit from this crop. You know, you're giving it that environment. You're making it happy essentially to produce what it is, and you're taking from that. And consistently, as opposed to a field crop where you're getting 1 to 2 turns a year, depending on where you are in the world, right? So you have very limited output in that situation. You know, maximizing light, maximizing the sun, obviously it's key to what we do on a daily basis. So that structure being taller, for example, now, when we talk about the evolution of greenhouses, we've got greenhouses that are 7.3, 7.5 meters tall, you know, 27, 28 feet high. And what that does is it creates a safe buffer from the elements. Like, so from the top of the canopy of the plants, there's a nice gap between that and the top of the greenhouse itself. So if it does change outside from a heat or cool perspective, that shock doesn't come to the plant right away. Using the climate screens and using systems as well, you save it from that as well. So it's just making that ideal place and house for a living plant to perform the way it wants to perform. And you know, we've touched on some things, but there are a lot of things that you can put into a facility, and it's specific to where that facility is located, because the environment outside obviously affects what's inside. So producing heat, there are different ways to be able to produce heat in the greenhouse depending on where you are. It's not always boilers, right? There's lots of new technology. It's an exciting time. We're using, you know, cold water to bring in dehumidification capabilities to greenhouses. And we're talking on a large scale, like acres and, you know, hundreds of thousands of square feet at a time. So it's a beautiful thing. There's a lot of excitement around it. And we, like our team here, especially like you can tell it energizes us. The excitement's real, and we love being a part of that, especially working with customers and setting up facilities for them and making it specific to where they are. So, yeah.
What about lighting? I mean, we haven't seen the sun for weeks. So, and I don't know what it's like in Leamington or Kingsville, if it's the same as here in Ohio, where it's just gray and dull for weeks and weeks on end. Do you have to have supplemental lighting for that?
I can take it, but I'll let my other guys jump on too. Like, it depends on that, on your crop. It depends on the operator, depends on what you're growing, and it depends on the capital. Do you need it? It's not needed. It's nice to supplement. It would obviously keep that vigor and keep your plants active. Is it a make or break? No. There's tons of technology around it. There's a bunch of new options coming to it. But yes, like if you can supplement the light, the sun, and the lack of sun, the plants will work. The plants will continue to grow, and they grow at a quicker rate, right? So then you take in consideration how you power that. And then you get into the world of, okay, now we do some maybe power generation on site, you know, and then we talk about furthermore, okay, if we're going to do power generation on site, what can we take advantage of the byproduct of that power generation, right? So with that power generation, depending on what you're doing, you can possibly have CO2 that you can bring to your plants. You can take the excess heat from the generation to heat the hot water that you're going to use to circulate within your structure. So, you know, yes, there's a possibility around it. There's a lot of options, and it always comes down to what the owner operator wants to produce. You know, we help with making that environment ideal, and then we go as far as they would like to go. We can take it anywhere.
Mm-hmm.
I want to bring that back also to the supply, up to the retail side of things, the light aspect that you mentioned, Tara. Some crops are able to convert light to enough extra kilos that the investment extra actually makes sense, tomatoes being one of them. In peppers, it's a bit more of a challenge. I have some people playing around with it. The need of year-round steady supply and this coming from one source is also driving this, where traditionally we would grow tomato crops. We would start picking sometime in March, and by US Thanksgiving, we would be done. Here's the winter gap. The marketers here would have to cover this gap, and they would then turn to Mexico or some other lower technology production systems with its challenges that come with it, the extra trucking, everything else. So certain retailers have said, is there a way that we don't have to make that switch? Can you provide us out of your facilities year round where you're controlled, food safety is not an issue, and so on and so forth? So that's how this started, where the light aspect came into play on a larger scale.
Yeah, that light is very crop dependent, like Burk said, right? Like we talk about how this industry is evolving. We talk about what kind of crops are coming into play now. And now you're seeing strawberry production being done on a hydroponic basis. You're seeing the leafy and lettuce being produced in greenhouses as well, because of the inability to control that from a field perspective, right? The elements are always going to be a key factor in these things, but from an ergonomic perspective, it's one. Maximizing production, it's another. So you're seeing more crops coming to greenhouses where they weren't existent before because of that consistent quality, availability, location, and obviously supply. We're talking about not having to truck produce or truck lettuce or strawberries, for example, from California. You're closer to the end user. Your shelf life's there, your quality, your fruit freshness is there. So like it's open. And with that evolution, it's just great to know that there is technology, there's things in place to help with that production of wherever it may be across our lands.
Mm-hmm.
Yeah, exactly. It's really basically trying to control the environment where the crop is growing the best. So in Holland, we've got studies that they have that they use certain kind of light, infrared or ultraviolet, and then it shows that certain crops are growing better under that than others. So it's really in fine tuning all the controlled environment to have an optimal harvest.
Yep. Yeah, like my colleague said, every type of plant has a different requirement, whether it's water, heat, or lighting level, and it's all about, I guess, meeting the ideal demands for whatever crop you're growing. So floriculture has a different demand than peppers or tomatoes or lettuce. So it does vary pretty widely. And a lot of these technologies they help us meet those demands and have the ideal output.
Thank you. I think I messed up on the slide deck, and the next one is the same. So yes, ignore that slide.
No problem.
I also spelled Stefan's name wrong, so I had to fix that at the last minute. All right. We're at the end of the slide deck. We still have 15 minutes left. If anybody has any questions, type them in the chat and we can ask them. If not, that's no problem as well. I'm not sure if I put an email address on here. No, I didn't. But if any questions come up, you can direct them at info@prospient.com, info@prospient.com, and then I can disperse them to one of the people on this panel who can then answer them for you. With that, I'd like to thank our guests, Stefan, Burk, Tony, and Joe, for spending their time today talking about sustainable greenhouses. It's much appreciated. It's a hot topic and definitely important in today's environment. So thanks very much.
Thank you very much.
Thank you, Tara. Thank you, everybody.
Thanks for having us.
You're welcome. Thank you. Bye.
Thank you.
Bye.
Bye.